Okay, for people who are joining this live stream, we are in the late stages of preparing the machine learning functionality for version 12 of Wolfram Language. And I think today we are simply finishing off documentation of some functions and doing what we call knitting, which is connecting functions into pages that they should be mentioned from. Okay, let's take a look at rarer probability. So how general is rarer probability? Does rarer probability work on the distributions, on symbolic distributions and things, or does it only work on machine learning?
I hooked up something. Actually, the first example is on normal distribution. And so, yeah, it should work. We should probably, someone in the statistical team should probably review it. Maybe there's some standard that I didn't comply.
Prob A is a little weird here.
Yeah, it could be just P.
Let's just do this. Compute the probability to obtain a rarer value, rarer sample, rarer value than 3 from a normal distribution?
Yeah.
Oh, well, that's just some bug.
Which build do you have?
I have no idea.
Should have been gone by now.
Okay, all right. So this is a general function that we can put on these pages. Has it been connected to CDF? I mean, it's connected here to PDF and CDF. Why isn't it mostly connected to CDF?
I mean, honestly, I mean, it's I think it's closer to a PDF than a CDF.
Fair
like
enough.
it's
okay.
it's
right. Well, we should refer to it here. Maybe after hazard function, we should refer to this.
Yep.
I don't know whether it's relevant to survival function and things. I don't know enough about what those are, actually.
But yeah, definitely after probability expectation. I mean, it's kind of it's a sub-case of probability, really. So
I think we could put it at the end here.
Also in CDF, I think we should put it after probability.
Okay. Does it belong with quantile as well?
A little bit, yeah, yes.
Should we put it at the very end? No, I don't think so.
Maybe.
Well, integrate these things. These are, I don't know. I think it goes after n probability.
Yeah, or just in front of histogram. I don't know. Maybe both are fine. To me.
Someone on our live stream is asking how to replicate various forms of general linear model using neural nets. That's a good question. I'd like to know the answer to that too. What combinations of layers are necessary for a particular form of regression?
I mean, for linear regression, it's just a linear layer. For logistic regression, yeah, it's just a linear and a softmax layer.
We should put that in, properties and relations for those layers and for those functions. It's a good suggestion. It's a useful thing for people to see. I'd like to see that. I mean, it would be useful to see from our linear model fit how what the correspondence is with the actual. I mean, I don't know what the how. Oh my gosh, all this stuff. How does linear model fit? How does that fitted model correspond to a neural network? Right? How do you go from that data to the trained neural net? Like if I did this with NetTrain, for example, what would happen?
So you have to separate the X and the Y.
What would I do here? I would basically say so what do? I transpose these? Is that what you're saying?
Yep, and then you can put
yeah, and then I put an arrow between them.
arrow.
Yeah, so I just say rule that. And then I would say
net train of linear layer. I think it just works. Linear layer on this, I think it just works. It has all the information that it needs. So there you go. Doing a logistic regression, linear regression.
Okay, so hold on. So what's this going to do? So that gives that result. So now if I say value, let's say it's at 2.3 here. My golly gosh.
Same thing.
Isn't that amazing? That's cool. Hey, we got to put this example in. This is a good example.
Yep.
This is very useful. And it will be nice to see how all these residuals and all that kind of thing fit in.
And for this case, it will give, same result. I mean, up to the optimizer.
Okay, can I, let's see, I don't think I can find the right place to put it in here. Can you guys figure out where to put this in?
So in relations and, property and relations.
Boy, oh boy, okay.
You don't take much risk by putting it there. That's fine.
All right, okay, I'll just put it in. But then it should be netted into some other places because this really is an interesting and useful example. And thanks for the suggestion, Mohammed, on the live stream. Where am I going? Examples, delimiter. So here I want to say linear model fit. Well, let's see. Here we have to show linear model fit applied to those numbers.
Yeah. So probably copy the first example.
Oops, why didn't that work?
Put the variable names and so on. With comma x.
Very simple. Do the same fit using a neural net with a single linear layer. Or should we give this? Should we put this in there? Let's put this in there. Why don't we just say rule at that? Doesn't that work?
Yeah, to work as well. It's a bit slower in this case. But when you have many features, it will be much faster to use and many examples to use a neural net version.
Okay. Anyway, I'm going to let you guys knit this correctly into other places. But that was a good suggestion, and that's a useful. And as a matter of fact, another thing we need to do here is to point this thing at linear layer, right? I think this should point to linear layer as opposed to, what do you think? I think just point to linear layer.
Yeah, definitely.
And linear layer should point back to linear model fit. Which of course it doesn't. Oh, excuse me. Okay. All right, let's go back here. Seth on the live stream says that rare probability is relevant to survival function. A one-sided p-value is a survival function. Not an unreasonable comment. So let's see, where were we going there? That was rare probability. Does it point to survival function?
No.
Where should it do so? Should it do so before quantile?
Before, yeah.
Directly before or just after CDF?
No, let's have a look at survival function. Oh, okay.
I think here, again, just
greater,
like...
Yeah, it's super related. It's greater than, okay.
So where should we put it in here? Before PDF, perhaps?
Yeah.
Okay.
And then survival function will be pretty high into rare probability. I think even, I don't know, CDF is loosely related. Yeah.
Survival function is 1 minus CDF, Seth points out.
Actually, I realized I put the, okay, I put the alternative way of computing rare probability on top.
Okay, let's do some knitting here. So let's go, let's see.
For this one, there's so many guides that are related to statistics. I guess actually we could look at survival function and wherever this is.
Yeah, well, let's do that. Okay, so here, where are you suggesting putting it here? Are you suggesting putting it in, I'm not sure if it really belongs here. We don't even have probability, though we do up here. Do you think it belongs with these? I think it's really not. I don't think it belongs quite with those. Random variables. Yeah, there it belongs.
Yes.
So maybe we put it after, since it's less well known than these, let's put it at the end of that list. Since people mostly won't know what it is. But in the distribution-related functions,
yep, just next to survival.
well, should we put it above since it's more general, or should we put it below both of those? Okay, how would you describe it here?
The same way we did in documentation. Probability, so okay, survivor already function, other function of failure rate. No, so they don't explain much here. They just probability to generate a rarer to obtain, yeah, to generate.
Probability for a rarer event.
Yeah. That's good.
For any rare event? For a rare event.
Yeah, a rare event, I think.
A rare? Okay. Okay. And you had another suggestion here on random variables.
I mean, yeah, I was mainly looking what PDF and probability were.
Oh, we just put it on there. We just put it on that one. That was the one. Yeah. That was the place we just put it. Okay, so let's just look at survival function.
Exactly.
And also, did we put it in a machine learning place or not?
We didn't either. So.
Okay.
Yeah.
Okay, survival function, we have things like reliability analysis, which I don't think is relevant to this. Okay, so I think rare probability now needs to go on a machine learning page. Which machine learning page? I mean, we've really only got one machine learning page, which we've got to break up at some point soon.
Yes, we only have one.
Well, we have the neural networks page. This is an unbelievably complicated page. I don't think it belongs on this page yet.
Neural networks? No. Definitely not. And this, where did you put find anomalies? Here you go.
Well,
maybe it's really related to anomaly detection. For in the context of machine learning, this is for anomaly detection. So.
And why isn't it on this page? Oh, it is on this page. Well, all right, let's add it just
or
on
learn distribution. Next to learn distribution. I mean, did we put learn distribution already?
I sure hope so.
Probably did. I mean, yeah. Automated structure.
Should we put it as just on this line at the end? Rare probability?
Yeah. I mean, it's yeah.
I think we just need to give people a fighting chance to find it if they want it.
Yeah.
I mean, eventually we'll probably want to break out a separate page for anomaly detection.
Yeah, when we'll deal with sequences and so on.
Right.
Still have some way to go.
Okay. All right, what's next?
Compute uncertainty. There is everything to do here. So we could do that. I could also maybe give that to Roger and Jose.
What is it? What is that for? That's for.
So this is to return a number with an around instead of just a number. And so I did the documentation page. Like I asked Jose, said, yeah, fine, do it. Because I assume it will be in this department eventually. And the reason I did it is because only my function use it for now. So
yeah, well, that I think is a ridiculous claim. This thing here.
Mm-hmm.
And corresponds to one standard deviation.
Yeah.
Let's just say that. Certain interval generated typically corresponds to one standard deviation, whatever that means, because who knows what that means. Yeah, I mean, this will obviously be included in things like fitted, the fitting functions and so on.
Yeah, I think it can be placed in many.
All right, okay. So let's take a look at where this goes. Classify measurements. I'm not sure this is going to find a good guide page. Home. Well, let's see where around is on the guide
There is
pages.
this number with uncertainty that I heard about. Exactly, it's where around is supposed to be, I think.
Okay.
Generating object with uncertainty. Perfect.
Okay. Oops. And fits, training, etc.
In fits.
Well,
I guess one day, yeah.
Generate uncertainty.
I mean, it's in everything. I mean, this is.
Okay, option to generate uncertainty in
any, or you say, not any, but it's or do you say approximate computation?
Well, let's say in
numerical computation.
No, because that will confuse people, because then they'll think it's like precision.
Yeah. In statistical computation. Actually, for now, they're all statistical computation.
Yeah, I understand. Okay. All right, fine. We'll say that. This will eventually have to be changed. Okay?
Yep.
Learn distribution.
And by the way, computant uncertainty, I mean, yeah, you already read it. Okay, fine. Learn distribution, I think we just have the knitting, although you didn't look at it carefully. I mean, you eyeballed it a few times already. It's probably fine. Yeah, you actually suggested some change. Now I remember more.
That's an almost circular definition you have there.
Generates learn distribution. That's what we did for classify. Classify generates a classifier function.
No, but only after we'd had a previous definition that says it tries to classify.
True. I mean, this, yeah.
No, actually.
It's true. We don't say at any moment what it means to learn a distribution in a way.
Generates an approximate distribution, data distribution or something. What should we say? An approximate distribution?
I mean, it's attempt to infer the underlying distribution of the examples.
Which attempts to represent the underlying distribution
of the examples given,
from which the examples given could be generated, or just underlying distribution from which. What do you think?
Example, I mean, distribution of the examples probably.
Okay.
Of the examples given. Represent, I'm not sure about represent. A learned distribution.
Generates a learned distribution which attempts to give, to be the
to model.
Well, but it represents it. That symbolic thing represents it. There is an underlying distribution. We just don't know what it is. No, there isn't necessarily an underlying distribution.
Actually, there is in that case. I mean, in the hypothesis that it comes from a distribution. Yeah.
An underlying distribution for the examples given.
Actually, I realize we never really stated the classic hypothesis of machine learning, which is each example is sampled, independently from each other. Things like that.
Okay.
I realize maybe we should write that at some point.
Yes, we should. Generates a learned distribution which attempts to represent an underlying distribution.
Okay. So we could say each example is assumed to be independently.
Each of the example I is, okay, learned distribution effectively assumes that each of the example I are independently, what are we going to say, are independently drawn from?
Yes, from their underlying distribution.
Are independently drawn for an underlying distribution which learned distribution attempts to infer.
Yep.
What are you using as the keywords for this creature? That is a distinct lack of keywords. Come on, we got to do better than that.
Not many. Okay, well, there's a lot. Density estimation is a classic. Generative modeling.
Okay, you're going to have to fill a bunch of these in.
Yeah.
It's not really data inference, is it? It's distribution. I mean, but think about specific cases like images, for example. I mean, we probably need things like that.
Yeah, I mean, there's always statistical modeling.
I'm going to let you fill these in.
Yeah.
Okay, so now what is the issue here? So the issue is, does learned distribution have the appropriate
well, there's one thing that I forgot to do is to tell that you can use information on learned. Oh, it's probably more on learned distribution.
Okay.
Although we could put it on learned distribution as well. I mean, I could write down, I guess.
Okay, hold on. What was your concern about what was in here? Because this seemed to be reasonably good to me. Learned distribution.
It has been needed. Yeah. I mean, it's been needed at least in the machine learning. I don't know if we want to put it in another guide page.
Like the statistical distributions guide page.
Yeah, I don't know. We could see where fine distribution is and follow.
Okay, hold on. Let's take a look at that. First of all, let's check that fine distribution actually has. Where should it go here? After fine distribution parameters?
Yeah.
Okay, so hold on. Let's find where learned distribution goes, and then
let's put fine distribution as well, and learned distribution.
We should, yes, and learned distribution. Probably is it not there?
Yeah, it is.
Yes, it is. Okay, what's data distribution?
This is very similar to learned distribution.
Okay, so let's find out where that's mentioned.
True.
Let's first of all check that data distribution points to learned distribution, which it does not.
This should point to learned distribution, because data distribution is actually the object.
Okay, so where should that go?
Probably.
Let's put it at the end.
Yeah.
Because it's a high-dimensional creature.
We should actually.
Okay, non-parametric statistical distributions.
That is, yeah, that's definitely the place. So data non-parametric distribution object. So yeah, learned.
Okay, I think we should have a thing here where we say
it's kind of
machine
generic
learning.
Yeah.
And then we can say well, learned distribution, general distribution for any kind of data. Now, do we want to give any other functions here?
Yes, learn distribution actually. In this page, you have both training functions and.
Okay, so should we just list that on a separate line here, learn distribution, and do we want to have any of the things like let's see, what are we trying? Go ahead.
I don't know, I'm thinking like even predict, classify, it's.
All right, let's do this.
But,
let's do this. Let's put on this page, learn distribution. And then what about the anomaly detection things and so on?
It's very related, yeah. I mean, this.
Arguably, learned distribution should be at a higher level in these statistics pages.
Yes.
Okay, so what else do we want to put here?
I mean, predictor function is kind of a distribution, actually. If we are talking about distributions here, and classifier function as well. It's just a conditioned.
Okay, and let's point this over to machine learning.
Conditional.
Okay, so I don't think this is really an adequate place to put this. Let's see whether we've got derive statistical distributions. I think you got to ask the statistics team where this goes. I can't tell.
Yep.
Okay, we've got.
That's okay. This was already done, actually.
Those are already done?
I was thinking we should put these two in data transform and thing, but they were already there.
Okay. All right. Oh, Seth on the live stream suggests manifold as a keyword for learn distribution. I assume that we point learn distribution to the dimension reduction stuff. Do we?
Yes, I think so. I wonder if we go the other way around, though. This, we didn't do, I think.
Okay, where should it go?
I think after feature extraction. And synthesize missing values. Let's put there as well.
Where?
Because
where should that go? At the end?
No, after cluster classify, I think. Because it's one of the application.
Do we point learn distribution to synthesize missing values? Yes, we do. That's a good name, by the way. That thanks to people on the live stream for coming up with it.
Spend some time on it.
Right. People actually understand what it means, which is always good. Okay, dimension reduce. Should we be pointing that to learn distribution?
Yes.
Same place after feature extract?
Yeah. Or maybe after close principal components. Maybe, yeah.
Okay. Okay, so in here, presumably dimension reduction has manifold and things like that as keywords. Well, it seems to, why is this, why, Sushma, that's a question for you. Why are these tentative?
Because Brian is supposed to review it.
Okay.
I don't know who put that. I've never put anything there.
No, yeah, Philip Bloom put that there, but it's a project that they're doing of adding keywords.
Okay. What do we want to just manifold for learn distribution? I don't know. There's got to be other meanings to that. What's that?
I don't know, manifold learning.
What? Say that again. What?
Manifold learning. You know.
Oh yeah, right. Is this related to the? By the time it's manifolds, is that the whole topological data analysis? Is that related to this?
Manifold is really like related to dimension reduction, right?
Yeah. I'm going to put it in here. I don't know if that's really related, but I leave it as an exercise to figure out whether that's actually related.
Dimension reducer function, we could link it to learn distribution, which I think we probably do it the other way around already.
We should put that at the end, learn distribution.
Yeah.
Okay. Anything else?
Jerome's items? Etienne, do you want to do it right now?
So yes. So text contents basically should do everything the same as text cases.
What do you mean? Should do everything? Should be in the same places?
Yes.
All right. Okay. Hold on. What did we change in classify? I don't remember changing anything here.
Classify? Yeah. It's weird.
Let's not change it. Okay. So you want to go.
And make sure that all the guide pages that contains text cases also contain.
Yeah.
And also check verify interpretation ref page.
Oh, yes.
What's the issue there?
I mean, that's a documentation page which you never saw, so we just want you to see.
Okay, well, let's take a look at it. What was it called?
Verify interpretation.
You know, I'm planning to try and do entity extraction on 4 million emails in my archive.
Mm-hmm.
I hope it's going to work. No. Look, verify interpretation to true. If this is the description, this is the wrong name. Right? It's an option for that verifies the interpretation, verifies that they can be interpreted, right?
Yes.
Verifies that.
Verify, but I mean, it actually removes the one that cannot be interpreted.
I know. Verifies that results can be interpreted as entities.
Sometimes it's not just entities.
Can be interpreted, can be semantically interpreted. Can be interpreted using interpreter. Is that a true statement?
I think so.
Can be interpreted using interpreter and removes those that cannot and drops those that cannot.
Yeah, I guess all of them are using interpreter. I wonder if we have one custom or...
Verifies that results can be...
I'm not sure. Actually, we wrote down typically interpreter is used to check if an interpreted form exists or not. I think there was one case. Oh, it wasn't using interpreter, but I can't remember exactly.
Then we got to say this here. Now, isn't there an analog of this in, if I'm not mistaken, image identifier? Wait a minute. Both text recognize. What does text recognize do? If it doesn't already have an option for this, it should.
It's not like acceptance threshold, huh? It's
what?
Because there's another filter, is acceptance threshold type thing. That filters when the probability is too low.
I know, but I think this should say verify interpretation somehow, because it's not quite the right terminology, but it basically means, is this in fact, does language identify succeed?
Text recognize.
Yes. Yes, I mean, in other words, look, can it produce gobbledygook, or does it have to be English? Right? Does language identify have to successfully say it's English? Say, I'm going to do text recognize with language to English.
I see. Yeah, I guess that could be at some point an extension.
I think that will be worth pointing out to Shadi, that we now have this verify interpretation.
Yeah.
Okay, so what are we doing here? Let's see, drops those that cannot. How did it recognize that as a city if it isn't a city? Or is it a city?
It is a city.
Then why does it say it's failure?
This is because we don't have it in our database.
But that's silly. I mean, how did it recognize that it was a city if we don't know that it's a city?
Because the neural network knows.
Oh, but that's ridiculous. I mean, that's a stupid example, if I might say so. I mean, in other words, no, I mean, it's just a bug in some. Okay.
Actually, you can infer from context here. I mean, I mean, okay, no, it is a bug of our database. That's true, but
so we shouldn't use that
arguably our
as an
database
example.
has an infinite number of bugs, right?
Yes, but we shouldn't use as an example something which is only there because it's a bug. And I don't understand why it's a bug. I mean, what type of a city is that? Why on earth wouldn't it be there?
It's a too small city, I think.
No, doesn't. I don't believe that. I don't believe that claim, because I think let's take a look here.
I mean, yeah. This is the main source of problem.
Okay, what's wrong with this? It's an arrondissement. Is it a city or isn't it a city? I don't think it's a city.
Yes, it is a city. I don't know the city very well, but Jérôme does. Let's see.
Okay, listen. I tried some places in England that recently that we don't seem to have, but it's complicated what they really are. You know, in the US, there's a much better definition of what cities are. I know France has very precise data on all of these different administrative divisions. Well, okay.
It is a city. I mean, yeah.
Well, what does he mean it's a city? Look, listen, we have a definite definition of what city is for our interpreter. And for instance, you know, like to take a more, you know, a bigger example, like Singapore happens to be both a city, a state, and a country.
Yeah, it is what's happening here. It's a city, but it's also arrondissement, and that's what this thing is picked in Wolfram Alpha. I think the city is missing.
I don't believe you. I bet if you dig into this, you will discover that at some level of, you know, municipal government structure, the thing is an arrondissement, but it's not.
Then it is. I'm on the Wikipedia page. It's I don't know why we didn't grab that, but it's a commune, and commune are synonym to city.
What exactly do you mean? It's a synonym. You see, this is where it's going to get squiggly. Okay. It's got a cathedral. Does it have a thick cathedral, or does it not have a cathedral? I mean, right. By the time it has a cathedral, that used to be
French definition. It's a city. It's yeah.
I don't know. And what does it say the population is?
Pretty
See,
low.
there it's saying 9,700, and here we're saying a much larger one, possibly because we're dealing with the region. So I don't understand that. That's a question for the curation team, which we should look into, because it mirrors some issues that I've seen recently with some English places that, look, back in my day were called villages, but I haven't a clue what their status is in terms of. All I know, and I was mentioning this to Alan yesterday, a few days ago, is when you drive into those places, they say "Welcome to blah blah blah" on a sign. So if that's your definition of cityhood, then they're cities. Okay, but this is really a bad example.
I wonder. I mean, okay, we should try to look for other examples. But
why don't you ask the curation people? I mean, why don't we think about a case where it really will be true that we think it's something, but it isn't interpretable, where it has the right
let's say
form.
19th century. Okay, yeah. For example, if you look date and you say it was built in Toulouse in the 19th century, I think 19th century cannot be interpreted as a date object.
Well, that's not really true. It absolutely can be. Just doesn't happen to be. Look, date object, 1900, 19th century. Let's say 1800.
It doesn't work on it.
What's that?
Yeah.
Century. Okay.
It's just that interpreter doesn't work on the.
Not yet, but that's a minor temporary thing that's about to get fixed.
Yeah. Okay, we could look for some.
Wait a second. What is verify interpretation really? Because what it's got to be really is the neural net learnt certain things, which interpolated certain things.
Mm-hmm.
So what's a more realistic example? I don't believe they're going to be examples in cities, but there could be examples in things like units where the thing makes no sense. Like, for instance, okay, and this may be incorrect, but I mean, negative value of kelvins of temperature would make no sense. But and we would probably know that at the level of interpreter, but we will not know that at the level of the neural net. I think this is a problematic function, I have to say. I think that what makes sense is, for example, in text recognize, whether language identified correctly says it's English, that makes sense. Because text recognize could validly recognize a sequence of things without, I mean, look, let's just look here for a second, okay? So let's take a Wikipedia page.
It is a very useful option, though. People have been asking for it for a while, and actually you've been pushed for it as well.
I understand. So let's look at Wikipedia data for Toulouse. And let's now ask for, so let's say text cases, string, comma, city. Is that right?
Yep.
And I say arrow entity or not? I just say
Arrow
comma, city.
Interpretation, yeah.
How does it know how many seconds are remaining? Is it looking at the length of the piece?
Yes.
Okay. All right. So now if I say city, arrow entity, how does our entity, oops, what just happened?
No, it's interpretation. And here you have some that will stay as string. Actually, yeah, La Ville Rose, the pink city, actually refers to Toulouse, like the windy city does for.
Okay, so that's a curation error. Again, that's a curation error. And Paris Orly is an airport.
It could be, okay, we can see, okay, it has two functions. Removing the curation error, but actually also helping the neural network. Because sometimes we are just wrong, like agglomeration is not a city. So the neural network is wrong. But if you put verify interpretation, it will make sure that it has been kind of vetted by our database.
How on earth will a neural net have concluded that agglomeration is a city?
I don't know. Because the context, and they live in, I don't know.
Right. Well, but so that's a more valid reason. I mean, we've got to explain that verify interpretation. I mean, yeah, this is a really bad example, if I might say so.
Okay, maybe we can talk again about this when Jérôme is present. I think that would be.
Okay, but I think we've got to be clearer here that verifies that results can be interpreted. Okay. I think we've got to say here something about how, yeah. I mean, by the way, it's really an interesting curation task to go through like things like, random web pages and so on, and do a comma city thing, then do city arrow interpretation and see what fails.
Mm-hmm. Yep. Yeah.
And then everything that's here is either a bug in the neural net or a bug in our interpreters.
I think there will be some nice interaction between text case and related task we're doing. And
right. Well, let's just do this. I mean, why don't we take 5 million pages from like Wikipedia and just do this on them with each of the different interpretations? Because everything that's a string here is some kind of error.
I mean, either text cases or
yeah, right. Either it's text cases or it's the interpreter. One or the other is wrong.
Mm-hmm.
For something like city, I think it's much less obvious, as I say. For something, well, I just don't know how sophisticated interpreter is with, for example, negative kelvins and things like this. I mean, why don't we try what's another thing here? Let's try date arrow interpretation. By the way, how fast is our entity extractor relative to other people's entity extractors?
This is hard to say because depending on the technique they use, I mean, if you're just spelling type thing, it's very fast. Here you go, you have a century that are, yeah.
Yeah, right. So this is, I mean, again, this will hopefully get precisely dealt with. In fact, you should send, Sushma, if you could send this to, is it Jeremy Michelson or is it Alan who's the right person for this? Send it to both of them.
Yes.
Okay. There's an example of stuff that should parse. Well,
Okay.
that's a weird one. See, that's a bug in the neural net. BC shouldn't be, I mean, I'm sure that goes with one of these things here.
That's weird.
Okay. I mean, this is really quite nice. Quite nice. I mean, and now if I take this, okay, so if I say interpretation here, and now I say, and this would probably be the example, verify interpretation, arrow true, then I will only get the things that are actually genuinely.
Yeah. I mean, programmatically, it's so nice to have that rather than have to do cases and blah, blah, blah.
Right. So if I now say timeline plot of this, okay, cool. So a lot's been happening in Toulouse or wherever this was recently.
1,200 as well.
Okay. Okay. All right. I think we should wrap up here, unless you had another thing you needed. What was the thing you wanted to do? You wanted to knit. You know what? I'm going to have to go soon, but to knit text content.
Yes.
Okay. We have a couple of questions on the live stream.
Honestly, we can do that because it's just taking text cases and we.
I don't think it's necessarily correct. Let's take a look at it. Questions on the live stream. Is there a way to use interpreter with your own entity store? I believe that is being worked on. And Sushma, that will be a good question to ask Tony. I know we discussed it, and I don't know whether it's an active project at this point. I mean, the main issue is to be able to add PLI linguistics, PLI-style linguistics to an entity store.
Okay, I'll ask.
And that's a little bit non-trivial because it's got to go through these patched Wolfram Alpha interpreters to actually execute the PLI if it's non-trivial. In other words, if it is part of the grammar rules system, if it's part of this system and it includes a non-trivial token, then it's got to basically call the Wolfram Alpha stack in order to resolve these things. But the fact is, some of these pieces, like fixed order, any order, all these things that aren't a grammar token can be done locally. But as soon as you have a grammar token, so for example, you were asking about popes like Benedict XVI. If you say, oh, for 16th, I might want Roman numerals, that will become a grammar token that has to loop through the full stack right now to get interpreted. But if you say it's literally, if you define that grammar yourself, or it's a literal 1/6 or XVI or something, then it'll be okay. Anyway, so check with Tony because I know we talked about that. Okay, and Mohammed on the live stream asks, can you include an example of how to import a Wolfram language trained network using MXNet format into Python, including parameters? I think you have the wrong group of people on this call to discuss that. The answer is there are supposed to be workflows that show how to do export of neural nets through MXNet into various kinds of harnesses, but I don't know the full details of that. Okay, let's take a look at let's see, we're looking for text we're looking for text cases. There's the places where it appears. So text analysis. I don't know whether text normalization is really what we would want for, let's see, text cases. I don't think that's really what we want. I don't know. Seems less relevant to text normalization.
True.
Okay, so let's go look at these other ones. Text analysis. Sure, that's relevant.
Definitely.
There. Okay, let's take a look here. Okay. Where should we put it? Here. And we would say, so what should we say? Generate a data set of contents of elements. Generate a data set of all identified elements in text. Of
it's
identified.
Not really all. Yeah. Some identified.
You know, I feel like this goes in a different place.
Content extraction.
It's more like text parsing, isn't it?
In parsing is, I mean, yeah, in a way, I try to tag a bit everything.
Yes.
But it's still extract. I see.
It's not really extraction. It's not really that either.
It's in between.
Yeah, it's kind of content.
You know what?
Content analysis.
Yes, and maybe we should. Oh, content analysis. Because maybe there's a title for both text structure and text contents, which is not parsing, but.
Well, no, but I think we do want to talk about parsing there. We do want to make sure that text structure points to text contents, which it does. And does text contents point to text structure?
This is more likely. It does not. It's rare that the new page, the old page has the link, but not the new one.
Oops. Yes. Okay. Right. That goes to text structure. Okay.
Then I think we're done.
Well, let's just check. We have got all the other pages here. Processing textual data. What's that?
It's you don't extract text.
It's not
extract data set.
It's not the same thing.
Oh, wait. Natural language processing, text structure.
Oh, that is the same thing there.
Yeah.
Okay. Okay, I think that's reasonable.
Yep.
Okay, I will push all these changes. Verify interpretation needs better.
Example, yep. Convey that to Jerome.
Right, and we need to do that loop with them. It's really, really, really going to be useful to the NLU, NLP.
Yeah, we're in communication with Alan's team, and that's what you meant.
Mm-hmm.
Yeah.
Yeah. I mean, basically, both sides can learn.
Yeah. And Jerome has good relation with them, so that's
good. Okay, we should really push on it for each of these categories, because we're going to get lots of good stuff for it. Okay, thanks to everybody on the live stream. Thank you all, and
bye-bye.
See you later. Bye.
Bye.